In this video, we'll take a look at the water pumping base model for the module known as Water as Shared Resource, and this is for Activity 2. What we're going to do is understand a little bit of the code behind the setup and the forever. So if we take a look here, we'll start in the world. And one of the things that we want to understand and be able to answer is who are the agents, how do they behave, what is the environment that they live in, and also figure out what happens each time through the run loop. In the setup, we'll take a look at the code from the top down, and basically it's resetting to the green spaceland. And then there are three procedures that are called in that order, and it ends with a create turtles and some other information here, and we'll come to this procedure in a bit. So make earth is here, and we have it's going to create one turtle, and it is size 51, which is really big size, and notice that it is placed in a very specific X and Y location. It has a color, and then it's going to repeat in this loop for 101 times a stamping, and then at the end of that the turtle will delete. So this is the brown. So what this is doing is creating the brown earth there. Make sky is very similar, except that the location is different and the color is different, and that's going to create the blue sky for our water pumping model. And the last one is make pump. And we should see here that the again, it's similar, but we have a much smaller size, a size of 1. It has an X and a Y, and it has a heading. So this means that we are specifying that it goes in a direction, and in this case it is towards the bottom of Spaceland. And it also is red, and it will repeat 49 times a stamp grid. Notice that this is a little different than the regular stamp. Stamp grid is only going to create a color on the spaceland that is one patch wide, and that is different than this one. Stamp is sensitive to whatever size this is and will make a large stamp area, whereas stamp grid is going to be only one patch wide. So in essence, this set my size is not necessary to use if we're going to use stamp grid. However, we include it just so that students can see the difference and be able to compare the code. After it does a red line, it will change its color to yellow and have a short yellow area, and that is going to create the pump that we have here. And the last part of the setup is to create a lot of turtles, and they are going to have a color and a shape and a size, and then it's going to call this procedure called create groundwater. Now if you look, we're in the world and we don't see that procedure, and that procedure in fact is in the turtle area, and we have it here, but it's called over in the world. And when I say call, I'm using this term here. This is the setup button is calling this procedure to activate it and execute it. So what's happening here, it's going to create, after those 1,000 turtles are created, each one is going to be positioned in a random location. And so this is essentially what the scatter equation looks like. And it is going to check to see if the terrain color does not equal brown, then it's going to redo this procedure. So that has a conditional statement that is checking for whether it's on a brown color or not. If it's not on a brown color, it's going to redo this procedure, and it's going to redo it over and over again until it ends up on a brown area. So this is called recursion because the procedure is called within itself until it no longer is needed, and so, or until it is fulfilled. So that is why when we hit the setup, we can see that the water is only located in the ground, not in any other location. Now let's take a look at the forever loop and understand what's happening with each loop through. And there are three procedures that it is going to execute: the groundwater movement, the pumping, and then the evaporation. So in this case, the groundwater movement has some interesting conditional statements. It's going to take a look at the if statement here at the top. If the terrain color that it's on is brown or red, then it's going to do this set of instructions inside. So it will evaluate this expression, and it will go ahead and run what's inside here if it will fulfill that. If it doesn't fulfill that, it will go into this else area. So if it's on brown or red, it's going to set the heading in a general downward direction, but each one might be a little bit different. It'll move forward one, and then it's also going to check if it gets close to another turtle, and that's what this one is, if the count of turtle within one step. So that's detection, and it's going to look to see, is there another turtle around greater than 0? If so, I'm going to back up a little bit, and this creates some interesting behavior that we'll take a look at. Now, if it's on a color other than brown or red, it's going to do this. It's going to set its heading to 270, which is also downward, but it's going to move forward 5, and that is much different than a forward 1. So it's going to be faster here than it is here. And the pump is a procedure that is going to also have some conditionals. It's going to check, am I on the yellow patch? And if so, I'm going that agent, that turtle, is going to be reset to a different x coordinate. So it's along the horizontal axis to -50 up to +50. And then the y is +50, so that's as high up on Spaceland as possible. It's going to create another turtle, and it's going to delete the original. And then the last procedure that it's going to run through is evaporation. And that one is also going to check, am I in the area, am I on a patch that is cyan color? If so, I'm going to head in a downward direction, and I'm going to check and see if there is, this is a percent chance. So percent chance of, it's basically a 5% chance of this happening. So random 100 less than 5 gives us a 5% chance. And if it fulfills this, if that random number is less than 5, 0, 1, 2, 3, or 4, it's going to shrink its size a little bit. So whatever its size was, minus 0.5, so a smaller amount. And then if it gets to a very, very small size, a tenth of a size, then it will delete. And so this is how the water molecules will get smaller over time. I'm going to speed it up a little bit. You can see that some of these water molecules are different sizes. And so we're not truly representing evaporation in the best, most scientific way, but it is a way to visualize that the water in this system is going away. Now, it would technically, in the hydrological cycle, go and make clouds and move into another phase, but in this case, it's lost to the system, and we're looking at the groundwater. So notice that there's this interesting behavior here, and the water molecules, when they get to the lower part of the ground, they will back up a little bit, and so they're very dynamic at the edges, but they are, and that is because of that code where it is detecting whether there is an agent there or not, and that's what this one is doing. So what's fun is to have students just take each part, and maybe they are assigned just one single section. Maybe it's printed out and cut, and they get to only see that one part, and then they try and articulate the code into their own language, and that is a really powerful skill for students to be able to have is to take that information and put it into sort of regular sentences. Thanks so much.